Hello, welcome back to Cracking the Cryptic, and we've been sent another puzzle by the Dutch master Aud van der Wetering. So I am looking forward to having a go at that. It looks very interesting. But before that, let me mention that on Patreon on the 1st of October, we are going to be releasing the Lockout-Lines puzzle pack, which is, I think, going to prove absolutely fascinating. Some absolutely brilliant constructors involved, and we really think you're going to enjoy it. So do join us if you haven't already on Patreon, or if you are there, get ready for the first. There is already on Patreon a solution video to the 6x6x6 Sudoku by Sam, which was brilliant, which we put up there last month just as a bonus, and all sorts of stuff going on. That's for the $3 patrons, the videos. Now, what else have we got? We've got all our apps, of course, and merchandise, and the links under the grid. Sven's SUDOKU PAD. Just have a look in the description field and you will see all the links to those great source of puzzles. And of course, the Discord server is carrying on with its fascinating discussions about everything Sudoku. Do have a look into that if you haven't joined it already. It really is a great source. Some very friendly and very brilliant people to talk to on there. Now, and don't be intimidated, because they are very welcoming and there are people of all standards. Now, let's have a look at this puzzle then. This is Aud all over. It's an arrow Sudoku, so the numbers along an arrow add up to the digits along an arrow, I should say, add up to the number in the circle. Normal Sudoku rules apply. Aud is generous enough to give us 4 given digits. He's old school like that. But he's not giving us anything more than 2 cell arrows. I think this is going to just prove fascinating. So do give it a try if you fancy it on the link under the grid. I'm going to start now. Let's get cracking. And this is one of those moments where I say that and then sigh and relapse into total silence as I stare at the grid, wondering how we can get started at all. I mean, we could observe that that has to be 1, 2, or 3, making that 6, 7, or 8, but it's hardly earth-shattering. You can look at these numbers and go, well, they have to be at least 1, 5, 2, and 3. That's 11. These have to be actually the same 1, 2, 3, and 5 minimum. So that's 22. And you might think that gives you a maximum of 22 for these, but it doesn't, because those two are adding up to a pair of this number. So that doesn't work at all. So there's very few limitations. I mean, okay, I think we've got 2 clues of how to proceed, and they're not really in the grid at all. One is that there is nothing apparently to go on in this grid, and the other is that the puzzle is by Aud. And what Aud has been doing lately is using all sorts of set theory. So I'm going to try and isolate some sets and see if that gets me anywhere. And I think these are the interesting across rows, surely, because they have all the circles for rows 1, 2, 8, and 9 in. So let's make them purple. Those are obviously 2 sets of the digits 1 to 9. Now these columns, 3 and 7, are also clearly 2 sets of the digits 1 to 9. So green and purple are exactly equivalent digits at the moment. And if we deduct these 4 cells out, which are both green and purple, we're still on exact equivalences. Now we could take out these arrows, but only if we accept that we're not using the same sets of digits, we're now using the same totals. So if we take out that, and this, and that, then we know that the total of the purples equals the total of the greens. And I don't think that helps at all. It's just so random. I don't see what that does for me. Okay, I don't like that. Let's go back. Let's go back to here. I'm going to now add in these other columns with arrows on to the green set. Now we have to bear in mind that we're not talking about exact equivalencies. We're talking about 4 green sets of 1 to 9 and only 2 purple sets. We can still deduct out the exact equivalent cells. Then we could deduct out these again. Why not? And we have to bear in mind we're coming down to equivalencies of totals. Oh, it's getting interesting now, because now the green has to be 90 more than the purple because it was using 2 more sets of 1 to 9. Now if we were to take out those purples and those greens, I want to take out these greens as well, but I can't entirely remove them unless I make these cells green. So I can remove those greens if I make that green, and I can remove those greens if I make that green. I've still got the same totals for green and purple. Now I've got a nice little butterfly, and we've got 90, the purples plus 90 equal the greens. Well, that looks interesting. The minimum for the purples is with 1s in those cells and a 2 there, that's 9. So is the maximum for these greens 99? 24, 24, that's 48. These could add up to 39. That's 87, and these could be an 8 and a 9. Which is 104. That's just 5 degrees of freedom. Is there some reason? I mean, that could be a 9. If that couldn't be a 9, I would be losing at least 2 degrees of freedom. I don't think there's constraints on those. This is interesting. Actually, I was positing the maximum here being 987654, which would make that at least 4. The maximum here would be 987, and that would make the other cells 7. They would add up to 11, which they can't do. So that's 2 degrees of freedom gone. We'd be down to just 3 degrees of freedom, but this is annoying. That's not doing the same job because there's a circle there. Under the, I mean, 3 degrees of freedom, these could theoretically be more than 1 by 3, but they can't actually be 4s because of the given 4s. So I can fill those in as 1, 2, 3. This could be 3 more than 2 though, so I don't know. I don't think this is enough, is it? It's these cells. These are annoying because they can just be anything. Actually, I've just thought, if that was 2 and 7 with a 9 there, then suddenly not only is that reduced by 2, you can't use the 9 3 times in these blocks. You can't, if it's there, you can't use it in that row. You can only use it twice. But I don't think that takes enough degrees of freedom off to do this. Now let's think about these blocks. They're in the wrong, they're annoying because they're so variable. Right, let's add these lines into the purple. I don't know, this could be madness. Then we can deduct all of these equivalent numbers. Now we don't have the 90 difference. Purple is exactly the same as green now, but there's not a lot of green cells and quite a lot of purple ones. And these, okay, we can deduct those out as well because green equals purple. Now there's very few blinking green cells. And these greens have to equal exactly the same as the purples. We must be onto something now. 1, 2, 3 and 4 there is 10. 1, 2, 3, 4, 5 there is 15. And we said the minimum for these other ones is 9. 24. To equal 9, 18, 27, 35. Ah, we're not onto something at all. The maximums are still huge. What am I missing now? Is there something else I can deduct here? Right, that green. What can I do? I don't even understand what I can do with this arrow. I'm sure I could make it some other way. Those two greens. Oh, I'm not understanding this. I'm sorry. I must be able to do something with this arrow and get rid of something. That plus that equals this. Let me just put in some numbers randomly to see what happens if I remove them from the totals. If I was to remove, if those were right, that adds up to 14 more than that. Then, sorry, that adds up to, the green adds up to 12 more, but that doesn't have to be 862. It could be 871, and the green adds up to 14 more. So I just don't think they can be removed like that. Unless, I don't know, there's some principle behind set theory that I'm just not getting here, I think. Oh, I see. Can I just make that purple and remove those two? If it was 8, 6 and 2, the green is 12 more than the purple. No, I need 2 of these cells. Yeah, that works whatever, doesn't it? If I have double this cell as green and I remove these 2, I think that's equivalent. That might help. That might help, or it might not. Wow, I'm not understanding this completely, as you can see. If it was 871, then it's 15, 14 is the difference. That is double that. If it was 835, the difference is 6, which is double that. Yeah, okay. Let's get rid of the colouring there. This now I'm having to count twice. Let's just sort of give it a part coloured thing. Let's remove the digits. So that, those 2 plus that twice is equivalent to all the purples, which are a minimum of 10. Oh, now 10 there, 20. These ones are 9, 29. From that twice, which could be an 8, but it couldn't be any more. But then these would only have to add up to 13 if it was an 8. Oh, it can't be an 8. This has to be at least a 5 on this minimum scale. Oh, hang on. Okay. Oh, this will do it. This will do it. Right, this is now 1, 2, 3, 4, but that would make this a 5, which would reduce this to a maximum of being a 4. And to get 29 with 8 there would require 21 here. That's no good. So this is more than 4. Oh, good Lord. Okay, I'm not quite understanding this, but I'm nearly there. So this is going to be a 9, definitely. If this was an 8, then that's a 1. Then these are 2, 3, 4, 5. That's the 4 degrees of freedom gone right there. These add up to 14. These can add up to 10. That's 24. These can add up to 9. That is 33. And I'm allowing this to be an 8 now. 16 plus 8 plus 9 is 33. That's what it's going to be. But can I prove? I just need to try this with a 7 here. I mean, what I'm trying to do is allow this not to have to be a 1 in case that's possible. If this was 7, that could be a 2. Then you'd have 1, 3, 4, 5 here. That's 13. 1, 2, 3, 4 here at the minimum, 23. 9 in these, that's 32. But now this is a 7. 14 plus 8 plus 9 is only 31. And that doesn't work. This is how it has to be. It has to be an 8 here in the doubled cell. It has to be a 1 here. 9 here, therefore. This is now 2, 3, 4, 5. That one obviously can't be 4 or 5. This is 1, 2, 3, 4, absolute minimum. These ones can't be 1, that one can't be 4. These are at the absolute minimum, 2 1s and a 2. These are at the maximum, 8 and a 8, I'm trying to type, and a 9. And this is our start. That gives us a 3 here. That must be the break-in. And I don't know, I may have painted that in a very complicated light. It felt very complicated to me, but it is how we have to start. I mean, the puzzle might solve from here quite straightforwardly, and I might be living in a fantasy dreamland when I suggest that. Really might. I don't know. Let's just do some mad good lifting of pencil marks. Those can't be 9. That can't be 8. That can't be 1, so this is a 2, 3 pair, so that's not 2 or 3. These can't be 2. Does that have to be a 2 in the box? No, I don't think it does. Oh, but that's a 2, 3, 4 triple, so the 1 in this column is here, in this row. I don't know why I said column, sort of thing I do. That means the 1 in this box can't be in those cells, so it's definitely on the 8 arrow. This 9 arrow can't be 5, 4 or 3, 6. This 9 arrow can't be 1, 8 or 2, 7. That's not very helpful. 1, 1. One of these is a 1. I'm prepared to bet it's on the arrow, but I haven't proved it logically. 2, 3, 4. One of those is a 4 for the row, so that's not a 4. Do I know anything more about this? I don't think I do. Okay, that's a 5, 6, 7, 8 quad. Isn't it? So that can't be 5. And these are also from 2, 3 and 4. Oh, that can barely be a 1 now that I was prepared to bet on. Only if it's 4, 1 gives 5. That's a surprise. 2, 3, no. 2, 3 pair. Do I know more about what this is? No, this is not solving simply from here, and I'm a madman for thinking it might. Okay, let's have a look at this arrow. We can't have a 1 on there, and we can't have a 4. So this can't be 5. Oh, it could actually. Bother. It can't be 6, because that can't be 1, 5 or 2, 4. So it's 5, 7 or 9. And this, I suppose there's quite a lot of possibilities. That's not that interesting, is it? Oh, 1 and 1. There's got to be a 1 on this arrow. Can't be 1, 8 makes 9. Can't be 1, 7 makes 8. Can't be 1, 2 makes 3. This also can't be a 4. 2, 4, 1, 8. So it is 5 or 6 or 7. Is that right? Have I missed anything out? It can't be 3 because we can't have a 2 there. Can't be 9 because we can't have an 8 there. Yeah, that's all right. So these are from 1, 4, 5, and 6, and one of them is a 1. That can't be 5, that can't be 4. Oh, this is more interesting. This can't be 1, 4, 5, or 9. It clearly can't be 2. It can't be 3 because we can't put a 1 there. So 6, 7, or 8, but I don't think it can be 6 because that can't be 1, 5, or 2, 4. So that is 7 or 8. If it's 7, this is a 2, 5 pair. Otherwise, it could be 2, 6, or 3, 5. So where does 4 go in this column? Well, in one of those two cells. Oh, that can't be a 4. Oh, that would have been... If I'd just eliminated that from this given 4 earlier, that would have been much more speedy and helpful. So we get a 4 here. I was going to pencil mark a 4 in one of those. Might as well do it since I've spotted it. So these are 2, 3, 4, 5. I don't think I have any way of telling which is which. Let's go back here. 1 is there. 9 can't be there. Oh, 9 can't be here. So 9 must be in one of these cells. So that can't be 9. This can't be 9. Ah, this can't be 9. Why am I saying that? Yes, 9, 9. Oh my God. More simple basic Sudoku. So we get a 9 there. 2, 7, 6. That can't be 5. So 7 and 8 are definitely going to be used in that triple. One of these two has to be a 6. And therefore these don't involve a 6. They also don't involve a 7 from that. So this is an 8. And that's a 5. This is now a 6, 7 pair. That doesn't have a 7 in. That's now 1, 8. This can't be 5, 4. It's 3, 6. That is a 4. This is a 2. Now we are cooking with gas. That's a 4. 5, 7 pair there. This is not a 4, obviously. I think this can't be a 1 now because we can't get to enough here. So my bet was so often totally wrong. We get a 1 there. We've got a 1 on this arrow. Now let's do this again. 3, 6, 7, or 8 needs, no, can't be 6 because that would put a 5 on here. 2, 6, or 7 along with a 1 somewhere there. Now this could still 7 or 5. Oh, it's definitely got a 2 on it, I think. It's either 2, 5 that way round or 2, 3 the other way round. It's definitely got a 2 on it. There's no 2 there. There's no 3 here. That's a 7, 8 pair. So we get a 3, 6 pair inside it. If this was, if this was 1, 6, that would be a 7. That would be a 5. That would be a 2, 3 pair, and this cell couldn't be filled. If that was 1, 6, we get 7, 5, 3, and that's impossible. So that's not 1, 6. That's 1, 7, making 8. That's lovely. Don't know if that's part of the solution path, probably not, but it's a nice spot. That doesn't fix this, but it does make this a 7. Now this has to be 2, 5. That must help. No 5 there. Actually, no 5 in the rest of that row. 2, 5, but no 5 here either. So this can't be a 6. So now we've got a 5, 7 pair in that row. We get another 3, 6 pair, which forms a bizarre X-wing on 3 6s. But never mind about that. It tells us where 4 goes in this column. It can't be here anymore. So it has to be here. Now we know that this arrow is 4 plus 1 is 5. That unwinds this X-wing, or no, that 5-7 pair, not an X-wing. So that makes 5 and 2 there. This doesn't sort out the 3-6 pair yet, but we will get to that. We can get rid of 6 and 7. That's now an 8-9 pair. This can't be, therefore, an 8-9 pair or 7. It is a 6. It must be 4-2, as it can't be 3-3. Oh, this is a brilliant puzzle, isn't it? 5-3, 4-2. Those are all unwinding, all the purple cells. There's one left. Yes, there it is. That's a 7 with a 6 below it. This is resolved. 9, 8, sorry, 9. Could see it was going to resolve, I just couldn't see how. That's a 7. Still haven't done that 3-6 X-wing, but this is a 7. Oh yeah, 7 and 1 are done. Ooh, all these ones in the bottom rows are not fixed. We can do 5 and 6. We've finished boxes 4, 5 and 6 appropriately with those. Don't say there's still going to be some difficulty over how these work. I've got all the arrow clues done effectively now. That can't be 3. 2, 4, 5, 3, 1. So, oh, so the only place for 7 in this column is here. That's probably been available for ages. 2 is down here. 5, 8, 1, 7. Oh, 8 has to be here. That might help. 8, 4, 1, 7, 2, 5. These, oh, they can't be 6. So this is 6, and that does this X-wing, which is going to be so valuable, I believe. 9 and 3 finishes box 1. What have we got to finish this? 6 and 2 finishes box 2. 9, 8, 6. We've done box 3. We are getting close now. 8, 9 there. That's a 3. That's going to fix all of these pairs. No, it's not. We're going to have to do them using these pairs. 6 and 9. 4 and 2 here. They must be doable. They are. Oh, what a crazy, crazy puzzle. I mean, if I hadn't known that it's odd and therefore it's going to be set theory, I could have been sat here for an awfully long time on this. I suppose I was sat here for quite a while. And I really missed the point early on, I think. And when I added in these rows, that made all the difference. What the areas I should have highlighted at first, I think, were those rows versus these columns. And maybe that should have been obvious because they had so many of the clues in. Oh, now I suppose in a way, maybe what one's looking at is those areas versus these areas, but that's difficult to see because, yeah, it's clear, I suppose, that the rows actually, looking at that, maybe it's obvious. If I'd highlighted this section, it's obvious that there's only 1 9 in the cells highlighted in columns 3, 4, 6, and 7, which is in the circle, because everything else is on an arrow. But maybe that tells you that you're going to have a 9 in the circle. I don't know. Yeah, what I was going to observe is if you just highlight what's left here. So these, they don't look that appealing, these purple cells, because what I was left with in purple, they're all empty at the start. It's not... No, I want to highlight the colours. So it's not obvious to me, looking at this grid at the start, that highlighting all those purples is going to be useful, because they're so indeterminate. And maybe you don't have to do this by using the double count on that cell, but I don't think I was getting there without it. So it was very helpful the way I was looking at it. Really interesting puzzle, as always, from Ard. That is half an hour of the most entertaining puzzling I've done for a long time. And thanks so much to Ard for sending it to us. Thank you for watching, as always. I hope you understood that a little better than I did as you were going through it, but an intriguing puzzle. I did really enjoy it, and hope to see you again soon on the channel. Bye for now.